This example, it asks you to factor this completely. So we have s squared t squared minus 2st plus 1 minus z squared. So there's a lot going on here, and usually when you factor something, you want to look out for a greatest common factor amongst all the given terms here. Unfortunately, there isn't a GCF from all four of these terms, so I'm going to take a different approach to this. I noticed that these three terms right here, these first three terms, I can do something with these. Okay. So first thing I'm going to do is the fact that there's two variables right here kind of bothers me. I want to try to substitute these as a single variable. So I noticed that the first term is s squared t squared, and the second term contains an st. So I want to substitute st as a single variable. So let's say that st, I'll set it equal to x. So what happens here, when I do that, I'm going to substitute all the st's as x. Right? So in this first term, we have s squared t squared. And if you think of it this way, s squared t squared is simply just st to the second power. And st to the second power can also be rewritten as x to the second power. So this whole thing is going to be x squared. And then minus, in the middle term, you have 2st. Again, st gets substituted as x. So you have 2x plus 1. And then minus z squared. So from here, for these first three terms, we have ourselves a quadratic trinomial, which hopefully you're familiar with factoring. And the way we would do it is you would find factors that multiply to give you the constant, and these also add to give you the coefficient in the middle. So basically we got to find out two numbers that multiply to give you positive 1, and those same two factors will also add to give you negative 2. And if you've worked it out, you should figure out that the two factors in this case is going to be negative 1 and negative 1, because negative 1 times negative 1 is positive 1, and also negative 1 plus negative 1 will give you negative 2, which fits into this term here. So the way you would factor it is you would have two sets of parentheses, and you would have the variable in question in both of these. So we'll have x in each set of parentheses, and all you have to do is simply put each of those factors next to the x inside each set of parentheses. So we'll have negative 1, and then we bring down the z squared. So now that we factor this, I'm going to go ahead and rewrite x as st again. I'm going to substitute it back in its original form. So I'm going to substitute the x as st. So this is all going to be st minus 1 times st minus 1 minus z squared. Now if you notice, there are two st minus 1s being multiplied together. So I can actually combine these together, multiply these together into a single term, squared. So this right here will end up becoming st minus 1 squared. And you bring down the z squared. So now that we factored the first three terms of this expression, we still need to factor the rest of this expression. If you notice right here, we have two squares. We have a square and a square being subtracted from each other. Now, this is what's known as a difference of two squares. So, difference of two squares. And this is a special type of quadratic that we factor in a specific way. So difference of two squares contains two square terms. So for example, you have a squared minus b squared, where a and b could just be any term, any number. And the way you would factor it would leave you with two binomials, namely the square roots of a squared and b squared, which is simply a and b. And the way that this is factored, you'll have your two sets of parentheses, and you'll have the square roots of each of these terms. So the square root of a squared is a, and you set of parentheses, and the square root of b squared is b. And in between each of these terms, you'll have a plus sign and a minus sign. And you can verify this by folding it all back together, but that's how you would factor a difference of two squares. So going back to the original problem, we have a difference of two squares right here. We have two squares being subtracted. So the way you would factor it would simply be the two sets of parentheses. You'll have two sets of parentheses, and you would have the square root of each of these terms inside of each set of parentheses. So keep in mind that since this whole thing is being squared, that counts as one whole term, the st minus 1. So st minus 1 squared, when you take the square root of that, you'll simply get st minus 1 in each set of parentheses. And then the second term, the second square that's being subtracted, is the z squared. When you take the square root of that, that should leave you with just z. So you have z over here and a z over there. And then you would separate each of these terms with a plus sign and a minus sign. And this is as far as we can go in terms of factoring this expression up here.